morning to all my 10th class students. Children, as you know that we were discussing about a very important concept of your chapter 2, acids, bases and salts, that is neutralization. So we have seen a lab demonstration of the neutralization of acids with base. Also we have seen some day-to-day applications of the neutralization. I expected some students to come up. Few have sent me, but I want others also to at least write up the day-to-day applications of pH or neutralization, how you are going to neutralize different things under day-to-day applications. Okay, so today we will talk about yet another very important concept that is linked with the neutralization, which is nothing but pH, children. It's called as pH. So what is pH? It's nothing but the full form of pH. P is written small and H is written in capital. It is nothing but potence of H, that is hydrogen. Potence means the value or the power of hydrogen. So we all know that all acids contain hydrogen in common, right? So this pH is nothing but the quantitative measure. It is not the qualitative measure, children. Hope you know the difference between quality and quantity. So it is a quantitative measure. Quality means, I'll tell you one thing. Just by using a methyl orange indicator or a litmus indicator or a phenolphthalein indicator, we are testing just whether it is an acid or a base, because we know that if you take litmus, if it turns blue, it is basic. If it turns red, it is acids. There we are just identifying or finding out the quality of the solution. We are just finding out the quality of the solution, whether acid or base or neutral substances. But pH is the measure. It is the quantitative measure. That means how strong an acid or how strong a base is, we are going to find out with the help of pH. Okay. So it is acidic, I know. How strong that acid is? It is basic, we know by using some indicators. But how strong a base is? So for that we need to have one reading. Like how for every physical quantity we have certain units, right? We have certain measure. Like if you want to measure the height of a particular thing, then how can we say that, we can just by looking at it, we can say whether it is taller or shorter. But how tall and how short, that we get from a universal or what you call standard unit, isn't it? So we just measure it with help of inches or feet or whatever. So this is the measure of the strength of the acids and bases. Hope you are getting the point now. Did you understand? So pH is a measure. How are you going to measure strength of acids and bases? I already posted you in my previous classes one video regarding the strength of acids and bases, isn't it? With one animated video attachment. Did you see that? So please go and watch that video first if you have not seen that. Even if you have seen that also, watch again and you will have a very clear idea of what it is all about. The strength of acids and bases depends on the dissociation of the hydrogen that is present in acids and the dissociation of hydroxide that is present in bases, right? So that it measures how much of hydronium ion is produced in case of the solutions. For example, what is pH? I said the potence of hydrogen. That means the power of hydrogen. How much amount, the concentration of hydrogen. It measures the concentration of hydronium ions. So more the hydronium ions, more acidic, more strong acid it is. So it is nothing but it will be measured by this. So a solution which has got more concentration of hydrogen will have lower pH. That you should remember here. The lower the pH, the more acidic the solution is. Say for example, a substance A, a solution A has a pH value of 1.5 and another substance or solution has a pH value of 6. So out of this, which one has a lower pH? It is A. A has 1.5 only. So A is more acidic. Okay, children. So before we go into the examples of pH and all, let us just consider the pH scale here. So this pH scale consists of values ranging from 0 to 14 children. So what are the value range of pH? From 0 to 14. Okay. And as you move from your left to right, the values increase. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So as you can see here, when you move from your left to right, okay, the hydrogen ion concentration decreases. That means what? The acidity of the solution decreases. If the value is, say for example, 1, this is 1, 2, 3, 4, 5, 6. From 0 to 7, it is acidic in nature, the solution is acidic in nature, and from 7 to 14, if the solution gets the value of 7 to 14, it is basic in nature. So as you go from 0 to 7, the acidic nature decreases up to 14. You can see here, hardly any hydrogen ions are there, right? Now, as you go from 14 to 0, can you see like this? The hydroxide ion concentration decreases. You can see here, from 7 to 14, the basic nature of the solution increases. Okay, so we can say that values ranging from 0 to 7, values ranging from 0 to 7, they come under acidic nature. They determine the acidic nature of the substance. And 7 is neutral actually, children. So 7 is neutral substance like salts. And 7 to 14, values ranging from 7 to 14 indicate basic nature of the solutions. Do you understand this, children? So the acidic, neutral or basic nature of the substance is often specified by a change in the color, just like how we saw in the indicators, right? But here it is called as universal indicator because here not just one but several indicators are put together or mixed together to form this universal indicator. Like for example, it has water, it has monopropanol, it has phenolphthalein, it has thymol, blue thymol, bromothymol, etc. So all these indicators are mixed and prepared, and that is why it is called as universal indicator. So upon one, this is shown by way of color change, I said, isn't it? So it ranges from red and it goes like, through orange, through pink, through orange, green, and then towards the end it is normally violet or indigo in color, purple in color. So that indicates the basic nature. What you need to do here is, you need to check that universal indicator pH paper. It comes in strips. That strip you have to dip it in the solution you want to test, and then whatever color you get, that grade of the color you have to match with the grade that is provided as reference on the pH strip. Only the reference colors will be provided along with the pH scale. So you have to match it. For example, you got orange somewhere over here. Orange is around 3 and 4. So there you will be matching that grade of color so that you will know the strength of that acid. Understood? So in the same way, if you get purple, deep purple, then it is, you have to match it. You will see that the color matches to somewhere around 14. So the pH of that solution is 14. That means it is very, very alkaline or basic. Okay. So universal indicators, as I told you, that they are made by dissolving or by mixing several other indicators. So which show up a color at a particular pH value. Okay. Okay, children, so I'm going to send you one pic regarding the pH values of various substances that we know. Okay, please go through it very carefully, and please go through the textbook also and read the chapter once. Okay, and I'm going to give you the color chart also, so please go through it carefully. Okay, thank you.